Okay, today I think that, chapter one, again, sort of a introduction to global resource politics. We first, before we discuss all the, major issues in global resource politics, we need to, I think, first understand the general, overview of global energy system, and that's the goal of chapter one. I think there are several things I think we have to do. First, I think we need to figure out some of the major trends that are shaping sort of the current and future energy landscape. I think this is the first step, right? In terms of what's going on in global energy. The assumption here is that there's a huge paradigm shift. Okay, there are significant changes on the way in the global energy system, and we need to figure out what are these major trends that are reshaping the global energy landscape. I think that this chapter picks two important trends that I also mentioned last week. The first trend is, first, in terms of consumption. Okay, in terms of demand, consumption. Always energy politics is about, if you read this chapter one, energy politics is about demand supply, right? Balance between demand supply. And energy outlook, the key to energy outlook is to project the future demand supply balance. Okay, that's future energy outlook. So in terms of major trends, I think the demand side, what is most important trend is there will be a huge energy consumption growth, particularly which region? East Asia. That's number one trend. Okay, like here. There's a shift from west to east. This is number one important trend. There's a shift from west to east in terms of energy consumption growth. This is number one important trend. From the demand side, from the consumption side. Okay, and we'll get to this, particularly in specific what this means, right? So there's a shift from west to east. Very important trend. Second important trend, from the supply side. If demand grows quickly, particularly from the east, okay, and from the Asia Pacific, in more specific, then from which source of energy we are going to meet this demand? That's the second question, second trend. So the supply side question, right? Is it going to be oil supply or nuclear supply or renewable supply or natural gas supply? That's number one. The second, then from which region? If natural gas, then natural gas from which region? Is it going to be Russia? Is it going to be from the Middle East or Africa, right? What does this textbook tell you? This textbook tells you from the supply side, there's a huge turnaround of North American natural gas. So the major incremental supply will be from North America. This is second biggest trend. North American gas and oil production. Both. Gas and oil, additional gas and oil, from North America, Canada and the US. I think these two demand side and supply side changes will define the future energy landscape, these two. So every other change will revolve around these two big shifts. And this is the focus of this chapter 1. So today I'm going to, in reviewing this chapter 1, I'm going to elaborate on what this means. And in the second segment of this class, North American shale gas revolution. Why shale gas revolution? Or shale oil also. Shale gas, shale oil revolution in North America. What is it? Why is it important? And what are the obstacles? And more importantly, what's the impact? What's the impact of this on the global economy and global energy market, right? Particularly on this region, on the Asia Pacific market. So these are the topics for today. Now, again, shifts in the energy landscape. Many today in the field of energy, many say that energy landscape has changed significantly. You will see this a lot, over and over again, right? There are significant changes in the energy landscape, right? Both demand side from the supply side. And the more recent trend is that due to probably global financial crisis, the global energy consumption growth a little bit slowing down. Okay, that's the more recent trend. But we have to see from a much longer perspective, like by 2020, by 2030, whether or not, how much energy consumption growth will occur. We need to continue to observe closely. But over the last several years, expected growth in global energy consumption has slowed down a little bit, okay, which is a good news. Okay, has slowed down a little bit, but I don't know how long this will continue. Now, regional differences. I think this is important. These energy consumption patterns differ from region to region, right? So regional growth expectations shifted strongly eastward. And like I said, unconventional oil and gas will play more and more significant role in fulfilling the world's energy needs, particularly energy consumption from the Asia Pacific. Okay? So this makes sense. I mean, these two changes, big trends, consumption growth in the Asia Pacific and North American shale gas and oil revolution. These two, I think, make a perfect sense because Asia Pacific countries, their energy needs mostly LNG, natural gas. We use a lot of natural gas, Asia Pacific countries, right? So these two are very important. If you look at other sources of energy, nuclear energy, still a lot of uncertainty, right, in terms of safety. Nuclear energy, although they enjoyed a renaissance of nuclear energy several years ago, but after March 2011, the Fukushima accident, a lot of uncertainty and anxiety regarding the safety of nuclear energy. Renewable energy, a lot of progress. Renewable energy, a lot of progress, okay, particularly in Europe, although slowing down. Renewable energy consumption slowing down in Europe, but a lot of progress. Also in the United States, but there is infrastructure problem still. And shale gas revolution, natural gas revolution is delaying the development of renewable energy. Biofuels also important, particularly transport fuels. Okay. This textbook discusses scenarios, energy scenarios, or energy outlooks. This is something that you will confront a lot if you study energy. Energy scenarios or energy outlooks. Different organizations, they release different outlooks, right? Different scenarios. This is almost the beginning of any energy studies. Making scenarios, making projections for the future. And what do they contain? Mostly these energy scenarios and outlooks. They're usually in the form of some projections of energy consumption, supply. These two are very important, right? Supply, demand, right? Very important. Current and future projection, right? Or sometimes past, they compare, right? So these two are basic: consumption, supply, demand, supply. Then what's the role of technology, right? Technology, technology is always important. And prices and other variables. So based on these factors, they make scenarios, right? And who issued these scenarios and outlooks? The well-known, most famous scenarios, U.S. Energy Information Administration, U.S. EIA, under the Department of Energy, under DOE, they have this specialized agency for data collection, and they issue outlooks and scenarios. Bigger than IEA. We have IEA, International Energy Agency, but EIA is much broad, widely used. I use data from EIA a lot. And ExxonMobil and BP, they also release these outlooks and scenarios, although of different nature. Chapter 1 discusses how scenarios and outlooks by ExxonMobil and BP and EIA, IEA, they are different. They discuss that. IEA, they have many economists, energy economists, okay? And EIA also, or sometimes political scientists like me. They have hundreds of experts. And what do they look at? There are 3 types of scenarios, according to Chapter 1. Reference case. So for this, they proceed from current situation, okay? Current technological base, supply, demand, right, situation. So that's the reference case, okay? If things go as now, right, then demand supply will be like this, right? Then best guess, expected value scenarios. Okay, there are many different scenarios, but particularly ExxonMobil and BP, they sort of tend to have this kind of best guess scenarios. And finally, you have alternative policy scenario or alternative technology scenario. okay, or new policy scenario. If climate change, undergo significant changes, then we need to have really different types of, energy scenarios. Shale gas revolution, which is a huge factor, right? By such and such time, due to significant shale gas technology advancements, there will be enormous amount of shale gas and natural gas production from the United States. Although we don't know how much, but based on that technological base, they can, sort of make a projection of alternative technology scenario, right? Involving U.S. shale gas technological advancement. Then we'll get to world energy consumption. Okay, world energy consumption. Now, this textbook, if you read this, they have different tables here. Maybe we can. It's a very complex work in terms of, drawing a map of world energy consumption here, but most frequently cited information regarding, future global energy consumption is that global energy consumption will be increasing by 50%. By 50% between 2010 2035. Okay, there are different numbers, but this is most frequently cited number. 50% increase in energy consumption between 2010 2035, which is a huge demand consumption growth. And in terms of using different number, we will be reaching 340 million barrel per day of oil equivalent by 2035, which is the same thing as this is 50% increase. Okay. The problem is you have no idea how big this number is, right? 340 million barrel per day of oil equivalent. This is a tricky number. Tricky number. This is a combination of every energy source. Okay, oil, natural gas, nuclear power, renewable, or whatever types of other energy, and they turn it into oil equivalent. Okay, oil equivalent. The real oil consumption, do you know the level of real oil alone, oil consumption alone today? Because there are ways of sort of combining all the other energy sources using oil equivalent. Okay, but the real oil consumption today, 90 million barrel. Today, 90 million barrel per day. Okay, so this maybe today's oil equivalent. Maybe you can subtract. Today's oil equivalent may be much bigger than 90 million barrel, right? And there will be oil consumption number by 2035 also, which is much smaller than this. It's okay. I mean, whether you understand this, some idea of what is million barrel, how big is million barrel, you don't have no idea at the moment. It's okay. I mean, you will see this a lot. Okay, and natural gas, they have different units, right? Billion cubic meter, BCM, or sometimes BCF, sometimes TCF, trillion TCF, sometimes million ton. We have all different units, very different units, and different from energy source to energy source. Oil and natural gas, they have different measures, okay? But these technical units, it's okay. I mean, if you don't understand this at the moment, it's okay. The point is, there will be a huge energy consumption growth. That's the point. Okay? There will be huge energy consumption growth in the future by 2035 from now on, right? Then this is how you have to think. There will be huge energy demand. Then how we could meet this demand, right? From which energy supply source? That's the sort of a chain of logic here. Demand growth here, then where? From what energy source, right? Supply source. Before shale gas revolution occurred, we thought that we are approaching some apocalyptic scenario because we have no idea where, okay, using what energy source we can meet this much energy consumption growth. We were panicked about this, right? Because we were thinking that energy was depleting, okay? And technologically, we are not sure about these new technologies, renewable or nuclear. We are not sure, but demand is growing, right? So every country was panicked about this. Then we had this revolution, technological revolution, right? Then we are getting a little bit relaxed, but we are not sure how much shale gas, natural gas will be available, not sure. That's why energy outlooks, these projections are important, right? Like I said, world energy consumption will increase about 50%, okay, from 2010 level by 2030. Okay. Then the problem is, before that, drivers of this demand growth. We discussed this a little bit, right? What drives this, energy consumption growth? Factors driving energy consumption. There are several factors. Yes.
Population.
Yeah, sure. Three factors. There are three factors, right? You're right. Population comes first. Right, population. Then economic activity, right? The more active the economy, the more energy consumption, right? So the fact that energy will grow, that means that there will be many more active economies. That's what it means. And also there will be many more people born. There will be population growth on the earth. That's the meaning, right? So GDP per capita, then energy intensity of economic activity. The author of this chapter say that population is outside the domain of energy studies. A lot of energy, when scholars make projections for future energy consumption, they tend to ignore population issues. Rather, they include these two things, two factors as key: GDP per capita and energy intensity. So policymakers, they tend to focus energy intensity. They think that these two are much more important than this. So a lot of policy proposals are focused on reducing energy intensity, particularly the emissions intensity. Right? So, for instance, Chinese economy, energy intensity way high than the United States. That's energy intensity. Right? So energy intensity means ineffectiveness of the economy. Right? Regional energy consumption growth, like I said, there are regional differences. Okay? Asia, Middle East, in terms of population, half the world's population growth, right? 60% of income growth, right? There will be a lot of new people born, and a lot of economic activities are expected from Asia and the Middle East. So that in terms of energy growth, that how much energy growth? Energy growth from this region will be 70%. 70%. About 70% of global energy consumption growth will occur in the East. Right? The implication of this from a global energy perspective, it's very important to introduce effective, efficient, clean energy into these regions, right? Reduce energy intensity, things like that. Very important. China, India, very important. Those are important global goals, right? Energy system changes, very important. Or to make a smooth link between this rapidly growing consumption center here in the Asia Pacific to new supply center. How do we make a smooth, effective link between consumption center and new supply center? This is a new focus. Like for instance, link between consumption center in the Asia Pacific and new supply center, like for instance, North America. How do we make a smoothly functioning energy transportation system between Asia Pacific and North America? That will be one of important goals globally in the future. If these trends are right. If these trends are right. So these outlooks are very important. Those outlooks will make new policies. Global energy mix. Again, you will hear a lot about this. Energy mix. Energy mix, what is energy mix? Energy mix is, again, energy mix has important implications. Those are important for the economy, environment, and security, right? And energy mix is and the mix is changing now, okay? Although slowly. Currently, the energy mix is changing. Energy mix is usually expressed in terms of the ratio, the share of fossil fuel supply to non-fossil fuel supply. This is the energy mix. As simple as that. Okay? Energy mix is the share of fossil fuel energy relative to other energy sources, nuclear, renewable, and biofuels. This is energy mix. And energy mix has maybe national energy mix, then you have global energy mix, right? But one of the changes facing us is today constitute a critical turning point where this energy mix at a global level is shifting. The former past energy mix has maintained for a long, long time, right? But today we are approaching a critical juncture, right? After which new energy mix will be settled. So if you read this chapter, fossil fuel share, do you know the number for fossil fuel share today, at the moment? What's the share of fossil fuel energy currently? Do you know the current number? 82%?
34%?
No, no, it's a combination of all coal, oil, natural gas combined. What's the number for coal, oil, natural gas combined? 82%. 82%. Okay? This is the current number, 82%. That's the fossil fuel share. So the remaining 18%, right? The goal, what's the global goal? The global goal must be to expand non-fossil fuel share because those are clean energies, right? And that has been the goal for many years, right? Reduce fossil fuel energy. That's been That's been a very valuable goal for a long, long time. But the meaning of the global energy mix is changing slowly is that it could mean many things. Global energy mix is changing. What do you think that means? Global energy mix is changing. Do you have any thoughts on this?
For example,
How is the global energy mix changing today, although slowly? So that future, then we are shifting to what type of global energy mix, right? And if you read these outlooks and scenarios, then what do they portend? What do they expect, right? For by 2020, 2030, right? Then what kind of energy mix they have in mind, right? What do you think? Do you have any thoughts on this?
for example, this book says, this chapter says that actually India is planning to expand their nuclear power in the future because they want to, they know that they will face a problem of population in the future. So this non-fossil fuel tool will gonna help them in the future. So they want to increase the share of these non-fossil fuels in the future.
So do you think that the to expansion of this
Yes,
still prime goal, right?
I think so.
The biggest goal. And what's the status of this goal then? Is it going okay? Do you think that this expansion of non-fossil fuel goal, energy, is going okay, or confronting
I
some
don't really
problems?
I don't really think that it's going smoothly as it's supposed to, but I think the question is concerned about the security and how to use disposals of the the nuclear in a nuclear reactors. So this is like a huge problem for the environment, and that is why maybe it's not going really how it's supposed to.
Right, right. My question is that this author, what does he say? Like by 2035, will the non-fossil fuel share increase dramatically or remain almost the same? Remain almost the same. Even by 2030, right? Non-fossil fuel share, 18% will remain. Maybe inside, the content will be different, but the share, non-fossil fuel share, 18% will remain same. Not 20%, not 25%, right? Why is that? Then another question. How about inside fossil fuel, coal, oil, natural gas? Any shifting of positions? Coal number 1, right? Oil number 2, natural gas number 3. Right? Altogether 82.
Natural gas will shift to the first place, I think, in the future. Natural gas.
First place?
Yeah.
Oh,
I believe so.
that's an overstatement. That's an overstatement. Still, coal is, biggest source, right? Oil number 2, natural gas number 3. But if you read many outlooks and scenarios and reports, natural gas will become number 2 and oil become number 3. Okay? So there's a shifting of positions here inside fossil fuel. But due to natural gas revolution, 82% fossil fuel share will remain the same, at least until 2030. Which is good news, but at the same time, bad news. Even oil, due to shale revolution, there will be a lot of additional oil production from shale formations. So that we are not sure whether oil will remain as a number 3rd energy source. They might, shift back to number 2. Okay? So there is uncertainty here. Okay? So shale revolution is a good news, but at the same time, bad news. If you look at this, in terms of global energy mix. Natural gas. Now we are getting at natural gas. This chapter sort of discusses the details of nuclear power, renewable energy, but let's focus on natural gas. Okay? Focus on natural gas. You see, no fuel source has witnessed as much change as natural gas over the last several years. The most important energy. Natural gas is introducing a lot of changes into the global energy mix. Right? Because of natural gas, the entire global energy mix structure is being shaken because of natural gas. So a lot of changes occurring regarding natural gas since 2005. We'll get to that, why 2005. 2005 was a turning point for U.S. natural gas production because 2005 was the year when sort of people began to witness the beginning, the advent of shale revolution. 2005. Before 2005, American sort of prospect for natural gas was very low, dim. In other words, U.S. Was expected to import a lot of natural gas before 2005. Okay, so it was the revolution was like sort of a bolt out of the blue, a very quick type of revolution. The government even they didn't predict because a lot of things happened in Texas, done by small scale companies. The government didn't know. Business driven, small scale business driven. That's shale revolution. So that change began to be catched 2005. Okay, although before 2005 there were small changes, but 2005 sort of began to be witnessed by many people. And important thing, what are the effects of shale revolution on the global energy system? Right? This is important. First, I think you have to know what is it? What is shale revolution? What happened in the U.S.? You first have to know. Then, having known what that is, then you have to know what are the impacts. What's the impact on the global energy revolution? There are several changes are pointed to. Supply sources are diversified due to U.S. revolution. Supply diversity. That's number one change. Supply diversity. Because before U.S. joined the natural gas producer, natural gas market was so closed. Very small number of countries dominated the natural gas market, right? Particularly Russia and a couple of Middle Eastern countries. They dominated the natural gas market, global natural gas market. So even there was no market. There was no market. Highly monopolized market, right? So due to U.S. revolution, there's diversity. There's diversity. Okay, which is a good thing. There's diversity. Multiple suppliers possible. You know, U.S. alone doesn't bring this change. I mean, U.S. is a sort of outstanding supplier, but there are many more new suppliers. Yeah, we have to keep that in mind. Not only the U.S., we have new supply countries, right? If not the U.S., like Africa, Australia, right? These are new suppliers, meaning, I mean, the most important new supplier will be the United States. I mean, no doubt about it, the most important supplier. But the U.S. is not the only new supplier. There are many more new suppliers, okay? So there are diversity of new suppliers, okay? And second change, natural gas market and natural gas consumption will be growing, okay? Natural gas market is growing, natural gas consumption is growing, but particularly LNG is growing much more rapidly than natural gas. LNG. Sort of LNG is a liquefied natural gas. Liquefied natural gas. If you put it on the boat, that's liquefied natural gas to export, right? So LNG market is growing much more quickly than natural gas market. What does this mean? The way natural gas was produced and traded, there are some changes in this, right? That's the meaning of this. The conventional way of trading natural gas was piped natural gas, PNG, piped natural gas. Piped natural gas is possible only overland, neighboring countries. You can export natural gas to countries in your neighborhood, okay? Like Russia exported to European countries. Overland pipeline, PNG network, okay? You don't need ships, you don't need boats. But the conventional past market was PNG type of market, okay? The customers were mostly your neighbors, right? But the future natural gas market will be different. Future natural gas market will be about shipping through boats, long distance. So consumer supplier will be much more long distance relationship. So global market is possible. So global level LNG market is growing today. And key factor behind this is America. Due to US shale revolution, this global emergence of global LNG market is possible. That's the impact of US shale revolution. LNG trading, like I said, LNG trading is much more gaining in importance. LNG trading, right? Many more countries have, importing, exporting contracts today, right? And this textbook discusses long-term contracts versus spot contracts. Long-term natural gas contract is type of contracts in the past. Long-term contracts. Natural gas imports, exports were usually done in the long-term contracts in the past. Why is that? Why natural gas in the long-term contracts, like 20-year, 30-year contracts? You sign the contract, buyer, seller, meet in the same place. Sign a contract for the duration of 20 years or 30 years. This is natural gas trading in the past. Why? What justifies this? What justified this long-term contracts? What's the rationale for long-term contracts in the past? Like, for instance, Russia, Ukraine, or Russia, Germany, Russia, Italy, Russia, and many other European countries. They had long-term contracts over the last 20 years, 30 years. Right? So you cannot change the buyer. You cannot change the seller. Right? Sort of a 20-year relationship is built into a natural gas contract. Why? What's the rationale for this new, for this old type of natural gas trading? Because the market, in the first place, the market was seller's market. Seller had negotiating power. Because seller was like in terms of number, right? You have much more buyers than sellers. That's the nature of market, natural gas market, in the past, right? There is no choice because there are a couple of sellers, either Russia or Middle Eastern country. There may be Africa. That's it. So these sellers pick and choose from buyer who to sell, right? So they have power, right? They have power. Then, okay, I can understand that. They have power. But why long-term contract? Why this seller's power led to long-term contracts? What's your name? 손지수. Why sellers' leverage led to long-term contracts?
Maybe because it costs more to ship the gas. You need to build pipes.
Right.
Compared to shipping.
It's kind of project financing, right? They first get the money. The seller asking the buyer to give him huge sum of money that is required for the entire project, natural gas development project, which is huge usually. Natural gas project, very expensive, takes time, but they finance the entire cost from the buyer, right? But instead, the seller gives in return guarantee of supply, right? Security supply. So it's a mutually beneficial type of relationship. That's what Russia did for a long, long time, right? Then, shale revolution occurred. Natural gas market, global natural gas market began to shift, right? This is something a lot of people are looking into. Then, how would this long-term contract, traditional natural gas, PNG trading, how would this change? What will be the new trading format? Particularly LNG trading. This is something we are studying because there are a lot of changes today. There are a lot of changes. Russia is, right? Facing a lot of problems. Russia, European countries, they have negotiating problems, right? Because of these market changes, right? So these are good topics for your paper. Good topics. This chapter 1 textbook discusses spot market, the emergence of spot market, right, versus long-term contracts. So spot market is one of them. Spot market is the emergence of spot market is one of these new changes in the LNG trading. And last Wednesday we discussed this at the conference. This was the topic of last week's conference, LNG trading. Now, let's then discuss what happened in the United States. Okay, what happened in the United States? When, how, right? Before that, there's something else here. let's cover this first, right? Before we get to what happened in the United States, gas consumption, regional gas consumption pattern, right? Gas consumption pattern again in the Western region, only 20 to 30% increase, but again in the East, 90 to 110%. There will be huge gas consumption growth, right? Particularly in the Asia Pacific country. So in general, energy consumption will be bigger in the East than in the West, right? Particularly gas consumption, much bigger in the East than in the West, right? Because gas will be the major energy source. But you might want to pay attention to this. Demand is likely to increase in all major regions, okay? Although particularly in the East, but the supply sources for each region very different. This will be an interesting sort of a point. In other words, sort of you have a map where demand is bigger than others, then which demand region is supplied by which country, which exporters. Right? This is exactly what this means. And our textbook has a map. Right? It's not clearly seen, but we have a map. But my point is, the biggest arrow linking demand, supply will be Asia Pacific, North America. That's my point. That's the biggest arrow. You know what was the biggest arrow in the previous system? Linking Europe, Russia. That was the biggest arrow. There was the biggest gas consumption in the European continent. And the supplying country was Russia. That will change. That will change. Right? So there will be a lot of supplying, sort of arrowing, destination type of changes. This will be a very interesting exercise. Right? Now, in terms of Middle East and Africa, where and how they will be supplied, they will be supplied more than anything else, local conventional production. Middle East and Africa. Local conventional. Conventional meaning not shale. Not shale. Conventional. Just ordinary natural gas. Right? In other words, Middle East and Africa, yes, I mean, they don't have the shale technology. Right? So they still have to dig up from the conventional formation. Okay? North America, I mean, no doubt, unconventional. They don't need to import, local. North America, no import, already no import. and unconventional, shale and others. And conventional supplies are declining in North America. In declining and cost bigger. Conventional cost bigger than unconventional, which is very surprising. Conventional production costs more than unconventional. Asia Pacific, they will import, no doubt. The importing region. The biggest importing region is Asia Pacific. Mostly LNG. This is a big difference. The big difference between Asia and Europe is that Europe, they import from mostly PNG, pipeline. Just the opposite. Asia, mostly LNG. The huge difference, Europe and Asia. And Asia has some potential unconventional production. We are talking about China. If China succeeds in shale revolution, there will be unconventional production. But it's a distant future. Then North American shale, unconventional revolution. Let's discuss what happened in the United States, when, right? How much natural gas is from unconventional sources. This textbook has very standard information. They have very good summary at the end. Very good summary of U.S. shale revolution. Did you know that America is #1 natural gas producer already? If I had asked you this question, you might have answered Russia, who is the #1 natural gas producer as of 2013. You might have answered Russia, but it's not. It's the United States. U.S. is #1 natural gas producer. Since 2012. Before 2012, Russia, #1. But after 2012, U.S. Okay? Again, due to shale revolution. Combined with Canada, U.S. produces 25% of global natural gas production. 25%. Then what made this revolution possible? Two twin technologies. There are two twin technologies that made this possible. One is horizontal drilling. Second, fracturing, hydraulic fracturing. These two technologies. These two made shale possible. Horizontal drilling is unconventional. Conventional natural gas production is vertical drilling. Vertically. You extract natural gas vertically. Okay? But unconventional is unconventional because you go 3,000 to 4,000 kilometers. Go vertically, then you go horizontally. This is unconventional. This is horizontal drilling. And fracturing. Fracturing is when you go horizontally, you fracture the formation, the shale rock, using water. That's why it's called hydraulic fracturing, water. So water pressure fractures the shale rock. So when the shale rock is broken, gas comes out of the rock. That's shale gas. Shale gas from 3,000, 4,000 kilometers underground. So this technology, these two technologies, There are many, like, pictures about this available online. You can find out. There are many, many different pictures. It began in the Barnett Shale field, Barnett, Texas. Early 2000, Barnett, Texas. And acceleration, 2007. Acceleration. So shale revolution began in Texas. Began in Texas by George Mitchell, the Greek immigrant who passed away last year. Several months ago he passed away, but he set up his own company, shale gas engineering company. Then he tried over and over again, then he finally succeeded, then began to produce natural gas. Right? And it sort of began to produce on a commercial scale, 2007. Right? Then he sold his company to a big energy company. So he made a lot of money. After successful commercial production, he sold his company. Then shale revolution expanded to other regions. There are famous shale gas fields. The first shale gas field was Barnett, then second Fayetteville, Arkansas, then Woodford, Oklahoma, Haynesville. These are famous, particularly famous, these two. Fayetteville, Haynesville, huge shale gas field. Fayetteville, Haynesville. And Marcellus is much more recent production. Marcellus is in the northeast region, Pennsylvania, West Virginia. Also New York, the state of New York. But the state of New York banned the shale production. Shale gas technology, it's banned in New York, the state of New York. So only Pennsylvania, West Virginia. So it's moving from Texas to Arkansas, Louisiana. Haynesville is the eastern Texas. Barnett, western Texas. Okay, Barnett, western Texas. So began in western Texas, moving to eastern Texas. Arkansas, right? Then northeast, Pennsylvania. Now, there's a rapid production beginning 2009, okay? Beginning 2009, really began to pick up. 2010, 2011, increased 4 times, 5 times, dramatic increase. Because of that increase, the market began to fall. This is an irony. Because of overproduction of natural gas, prices dropped. Okay, I'm talking here about things that happened in the space of 2 or 3 years. 2009, 10, a lot of production. Then the market supply began to exceed demand because so much was produced. So the prices began to fall. So 2011, 12, what happened was the market is depressed. So this is important. As prices drop because of supply glut, oversupply. So producers, shale gas companies, they began to shift their focus to liquids deposits. So the Eagle Ford, another Texas shale gas fields. This is something that you might not understand. Okay, in the space of 2 or 3 years, overproduction, natural gas glut, then prices drop, then companies leave. They left shale gas fields. They moved to Eagle Ford and Bakken. Eagle Ford, Bakken, they're different shale gas fields. it's not purely natural gas. Eagle Ford, we call it liquid field, liquid. In other words, these shale gas fields, Haynesville, Barnett, these are all dry gas. Dry gas meaning when you extract it, natural gas comes out, and these natural gas are really dry natural gas. No liquid that comes with it, just dry gas. Okay? But Eagle Ford and Bakken is different. Eagle Ford, Bakken, natural gas is associated with all different liquid components. Like a oil liquid, and many of the different types of liquids, energy liquids. Liquids you use for LPG or butan, right? All these different liquid type of energy associations, okay, that come with natural gas. So companies move to this Eagle Ford, Bakken. Bakken, again, different than Eagle Ford. Eagle Ford, you know, they produce a lot of liquid content natural gas. Bakken is shale oil. This is how shale oil production began in the United States. Bakken, North Dakota. Right? It's an irony. Because of overproduction of natural gas, companies lost profits, moved to liquid type or shale oil fields. This is how U.S. shale oil production began. So shale oil revolution, which is different from shale gas revolution. Shale oil revolution began in 2011. Bakken. Right? The shale gas, shale oil. If you read this textbook, companies are moving to liquids because liquids are much more expensive than dry gas. You need to see those actually in person. You need to visit Texas, you know, different Oklahoma, then you will understand. Eagle Ford. Eagle Ford, very famous. Korean Gas Corporation, Korean National Oil Corporation, they have equity shares in Eagle Ford. They produce all different, you know, liquids and they sell it. So if you go to Bakken, what's going on in Bakken today? Bakken, it's you know, no one lives there. You know, just you know,
Forget about it.
right. But if you go there, kind of a boom going on there. Then what's interesting is that you will see a lot of you know, fires coming from the underground. That shows that these companies are working on shale oil. They still have a lot of dry gas coming out of the ground. Then they just burn it because the natural gas are not profitable. They burn the natural gas. This amount of natural gas flare enormous, but they just flare it because it doesn't give them profits. Under the current natural gas market, natural gas price too low because of overproduction. So they're waiting before natural gas prices come back, right? Then they're working on these liquids and shale oil. Now, the rest of it, you just read the final sections of this chapter 1. It's well summarized. And this chapter discusses also environmental problems that shale gas projects, right, raise. So you read about what are these environmental problems. And U.S. oil production, shale oil production, how much, what's the importance of it, read about it. Okay. Okay, I think today, right, before you go, maybe I want to toss out this final, statement. Shale gas production increased 13-fold, right, from 2005 to 2012. Again, we have another measure here, BCFD, billion cubic feet per day. So it began as 2 billion cubic feet per day in 2005, but 2012, 26 billion cubic feet per day today, right? Enormous increase. Shale gas now constitutes 30% of U.S. natural gas production, 30%. Right? 70% conventional natural gas. All right, Thursday, chapter 2.